Okay, so to go along with your Unit 4 Day 3 properties of graphs notes, on that worksheet, we have a list of different kind of properties of functions. We have domain, range, end behavior, minimums, maximums, even, odd, decreasing, increasing, and then some intercepts. So normally we would do this in foldable form, but I'm just going to use some notes here to kind of clarify what each of those are. So domain and range we should be pretty familiar with. Domain was defined as a set of all possible input values for the function. So just some facts about domain is that we can list it, as we know, in list form. And these are going to be all of our x values. And for our picture here, all I did is copied the same graph that you had for your do now. If I'm going to list the domain, kind of the way that we look at a domain is I start scanning my picture from the left, and I'm going to go until the right, and I'm going to see what I hit first. And in this situation, the first thing I hit is a arrow, and the last thing I hit is an arrow. So what that is telling me is that this is going from negative infinity to positive infinity, or we can write that as all real numbers. Likewise, with range was defined as a set of all possible output values. So these are going to, again, follow the same kind of information as a domain, except these are our y values. And I think I've mentioned this before as well, but when I do y values, I kind of scan my picture and work my way up. So in this case, when I did that, the first thing I hit was this number right here, which for the purposes of this worksheet, I'm going to write that as the point -2, -4. So my range here is going to start at -4. And then the last thing that I hit are these arrows up at the top, which are going to indicate that the top of the range is infinite. And that's how I kind of go through and determine my domain and range. I look at left to right, and then I look up down. The next thing we want to talk about is end behavior. End behavior was defined as the trends of the y values of a function as x approaches positive and negative infinity. When we're talking about our ends, we're literally talking about what's happening here as x, what's happening to the y as x approaches negative infinity, which is going to be the one here on the left, and then positive infinity, which is the one here on the right. End behavior should be described in terms of limits. But for the purposes of this class, we're just going to look at the cases of positive, positive, negative, negative, positive, negative, and negative, positive. Those are the four possible situations. And since here, again, on my graph, we have the ends that are both going up, our end behavior is just going to be listed as positive, positive. What this is meaning is that the limit of y as x approaches negative infinity is going to be positive infinity, and the limit as x approaches positive infinity for y is also infinity. That's our fancy talk, and you'll add that piece on in pre-calc and calc. But for now, we're just going to use the arrow signals, and in here, it's going up to the right and up to the left, so that is going to be our end behavior. So that's always a nice one. It's kind of like a quick little gimme when we're going into detail here. The last four that I want to look at here are going to be our relative maxes and mins and our absolute maxes and mins. So these have to do with the lowest point in a particular section of a graph, and then the lowest point for the whole graph, and then same thing for the highest point. So these do have to do with your y values. And the way that we want to think about this is that for my relative maximum, my maximum relative to this chart is going to be here. It's the biggest kind of like peak versus our relative minimums are going to be kind of valleys. So here I have a peak. So again, I'm just kind of ignoring the arrows. Infinity will never be relative. That'll always be absolute. So at y equals 0 here, this is the 0.20. That looks like a 1. At the 0.20, we have y equals 0 is going to be our relative maximum. So compared to the rest of this graph, this kind of peak that's happening here is at y equals 0. And if you want to give yourself a little bit more information, you can say that it occurs at 20. Versus our relative minimum, we have two values. That is occurring here and here. So those are the two valleys in our graph. So those are going to be, again, our valleys. And this should have been an orange. So here I have negative, so we have one at y equals -4. And also at -1. And those are occurring at, and then I'm going to just list the coordinates, -2, -4, and at 4, -1. So technically the minimum is the minimum y value, but it occurs at a point. Now I want to show you those in contrast to our absolutes. My absolute maximum is what is the upper boundary of our range? And since I have two arrows there, and again I want to show you the upper value of our range. So I'm going to switch to kind of green here. This is your total max. And that is going to be positive infinity. And now what I do like about this is kind of how I drew it here. Your upper max, so since it goes to infinity on both sides, but as long as it went to infinity on one, is always going to be the second portion of your range. And then if we want to find our absolute minimums, you want to kind of just, again, scan your graph. Where is my value the smallest? That's going to be the lower boundary of your range. So this is going to be total min. And so for this one, I'm only going to list y equals -4 or at -2, -4. And again, here, that's going to be the lower value of your range. So your range is connected to your absolute max and your absolute min versus your relative max and min really tell you all of those peaks and valleys, those bumps, those little moguls, if you're into winter sports, as we go through. There's a couple more on our list. We have to look at whether a function is even or odd. So even is when the graph is symmetric about the y-axis, and odd is when a graph is symmetric about the origin. If I had to categorize this as one or the other, we're going to say even. And the way that I want to go back to here is with your end behavior. These guys are going to be your evens, and these guys are going to be your odds. And that's just because of the nature of the graph. So linear functions, cubic functions, those are odd functions, and things like our absolute value or our quadratic are going to be even, where they go in both directions. But this particular graph is neither. And the reason that it's neither is because whether I'm about the x-axis or the y-axis here, if I were to draw this line, it's not symmetrical. And it would also not be symmetrical about the origin. That would mean if you could flip it upside down, it would look like it did on both ways. We're going to do a mini lesson on even or odd using algebra a little bit later, and I think that makes it a little bit more clear. Okay, my next one is decreasing. So this is when these are your x values, where y is going down. So what I want to look for when I'm doing this is, again, the spots on the graph in which we're going in our downward position. So going from left to right, the way we read, here I am going down, and in this chunk I am going down. So when I go to record this on my graph, even though that's the y values that's creating down, we list these with our x values. So I'm started at negative infinity, and I kept going down until I hit -2. And then I also started at 2 and kept going down until I got to 4. So those are my two decreasing situations. I'm going to keep that color up there, and let's look at increasing. So I'm increasing in those other spaces. As long as there's no constant areas, as you did with that walking graph, constant as in straight, not as in linear. As long as there's no constants, your whole graph should be colored in here. So for this one, I started at -2, and I'm ending at +2. And then I'm also increasing from 4 to positive infinity. And as you can see, these should really link together nicely. Like our whole graph, our whole domain is covered here. Our domain was from negative infinity to positive infinity. So I went from negative infinity to -2, from -2 to 2, from 2 to 4, and from 4 to infinity. We are also going to use smooth brackets here because it's not technically increasing nor decreasing at a single point. And so they just connect much better if we don't include any in our information here. And then lastly, x-intercepts. These are going to be the points x0, where at any time it crosses the plane. And so I'm going to pull a red here. And I like to, every time I get a graph, you're going to notice that I do these little X's on all of my x-intercepts. So my x-intercepts here look like they are -3 and 0, 2 and 0, and what is that, 5 and 0. I'm going to write that as if it's in a little list. And you can have many x-intercepts, but you can only have one y-intercept, and that has to do with the definition of a function. And your y-intercept is happening right here. Maybe you circle your y-intercepts. And those are always going to be points 0, y. So in the case of this one, I am at -2. So this is at 0, -2 on this particular graph. So that covers, if we zoom all the way out here to both of those situations, that covers all of those properties on our graphs. We had domain, range, and behavior, relative min and max, absolute min and max, even and odd functions, decreasing, increasing, y-intercepts, and our x-intercepts. There is technically another one, and again, maybe I'll go over this one more next year. It just doesn't happen to be in a standard for this year. Why can't I paste? There we go. There is one called positive and negative. So I'm going to do that in red and green because that makes sense to me. So here is going to be our positive, and then we will also do negative, not to be mixed up with increasing, decreasing. So increasing, decreasing, this was decreasing, this was decreasing. Positive and negative literally splits your graph into a positive zone and to a negative zone. And then you list the x values for each. So for negatives here, we were negative from, what was this, -3 all the way until 5. And we were positive from negative infinity to -3. And then again, I guess it should be an or. from positive 5 to positive infinity. So if you were to come across in any research or exploration that you're doing on your own time, this idea of positive and negative, how that differs from increasing, decreasing, that's probably good to know. And then while I'm doing some extra stuff here, I wanted to run you through some even and odd situations. So an even function, like I said, would be a quadratic. An even function would be an absolute value. An even function would be our x to the fourth polynomial, and things like that, versus, like I said, odd is going to be our linear function, and it's going to be our cubic function. And then we have some things that would be both, like we have a circle situated on a plane, which would be both even and odd. But basically, even has reflectional symmetry, if you remember that from geometry, and odd is going to have rotational symmetry. All right, so that is what I have for you guys in terms of notes. What you're going to do next is try each of the examples from Unit 4, Day 3. There are 5 of them, and then you'll check them against my key to see how you did. So I hope this helps. This is I think this is a really interesting topic, and I always enjoy dissecting each of these graphs.